When we think about AI writing code, we usually picture it spitting out a single function, right? Or maybe fixing a little bug here and there. But what happens when AI agents build an entire, complex, deep learning software system, completely from scratch? Well, let's get into it, because that is exactly what happened with a project called VibeTensor.
And this quote right here has a bombshell in it, and it's that little phrase, fully generated. Let that sink in. This isn't just AI assistance. No, this means human engineers basically just gave high-level directions, and then the AI agents just took over. They wrote the code, ran the tests, submitted the changes, all without a person checking every single line.
And that really is the big question, isn't it? What happens next? This project, VibeTensor, is one of the very first real-world examples we can actually study to start finding an answer. It's like we're getting a sneak peek into a future where AI isn't just a tool for a developer, but a developer itself.
All right, so first up, let's get a grip on what VibeTensor actually is. We're not talking about some simple little library here. This is a full-blown software stack designed for deep learning.
Okay, so let's pop the hood and take a look at the surprisingly complex machine that these AI agents managed to put together.
This diagram is basically our map of the whole system. So up at the top, you see the language bindings for Python and even Node.js. That's the front door, what a developer actually uses. Then that layer talks to the C++ core right there in the middle. That's the engine room, handling all the heavy lifting, like the Autograd engine, and figuring out which operations to run. And all of that funnels down to the bottom, the execution layer, which manages the memory and runs the actual code on the GPU.
And, just look at this list of components. It really drives home the complexity. The AIs didn't build a toy. They built a real PyTorch-style tensor library, a C++ core that supports GPUs, a proper Autograd engine for training, a memory manager. These are all the serious, non-trivial pieces you would expect to find in a production-level framework.
So we know what they built. But honestly, the really revolutionary part of this whole story is how they built it. This workflow, it could totally change how we think about making software.
So this is the vibe-coded process. The best way to think about it is like this. A human architect hands over the blueprints to a crew of autonomous AI construction workers. The architect just says, I need a CUDA memory manager. The AI agents then figure out how to build it, they write the code, and, this is the crucial part, they run all the builds and all the tests to make sure the thing they just built is solid. A piece of code only gets added if it passes every single check. And get this whole complex system, built from absolute scratch, took about 2 months. 2! That kind of speed is it's wild. It really shows you the insane potential of having agents do the development work.
Now, obviously, you can't just let an AI go completely wild. They had some really important guardrails in place. The tests were basically the contract. They spelled out exactly what the code had to do. The system's answers were constantly being checked against PyTorch to make sure they were correct. And they even had multiple AIs review each other's code to catch blind spots. Kind of like a peer review for bots.
So, okay, it's a fascinating process. It was built incredibly fast, but that all leads to the million-dollar question. Does the thing actually work? Can it really train a neural network?
And the answer is a big, loud yes. The proof is right here. These are the kinds of charts that every single machine learning engineer loves to see. On the left, you see the training loss just steadily dropping. Perfect. And on the right, accuracy is climbing higher and higher. This isn't just a pile of code that runs without crashing, it's actually learning.
And we're not talking about some simple little model either. They successfully trained a few different, pretty complex architectures, a transformer, a vision transformer for images, and even a small GPT-style language model. So the system is flexible, it has real breadth.
Okay, so what about speed? Is it as fast as a mature framework like PyTorch that's been hand-optimized by humans for years? Well, no, not yet. You can see it's about 3 to 6 times slower. But, and this is a huge but, that's not a failure. Not at all. For a first-generation prototype, where the main goal was just to prove it could be done correctly, this is a totally expected and, frankly, pretty great result.
But beyond just the performance numbers, this whole experiment revealed something way more profound. It actually surfaced a completely new class of bug, a type of problem that seems unique to AI-generated systems.
They're calling it the Frankenstein effect. And it's this fascinating idea where the AI agents, focused on making each individual part perfectly correct, end up stitching them all together into, well, a monster. A system that works, technically, but its overall design is globally terrible and it just cripples its own performance.
And this diagram right here, this is the smoking gun inside VibeTensor. To make sure everything was correct and safe, an agent put in this global serialization gate. You can see it right there, acting like a giant lock. Now, that component on its own is perfectly correct, but look at what it does to the whole system. It forces everything through this one single choke point, this bottleneck. It basically starves the super powerful GPU kernels down at the bottom. The body is strong, but the neck is just too thin.
So, the huge takeaway here is that the next big challenge isn't just about correctness. We're past that. It's about teaching AI agents the principles of good system design. We have to teach them how to build things that don't just work, but are elegant, efficient, and performant when you look at the whole picture.
And this leaves us with this really fascinating, almost philosophical question to chew on. As AI starts to shift from being just a tool to a genuine collaborator, a coworker, the real challenge becomes clear. How do we pass on that architectural taste, that design wisdom that separates a system that's just functional from one that's truly brilliant? How do we teach our new coworkers not just to be right, but to be wise?